Today we have a new lecture, integral for cotan to the power m multiply cosec to the power m dx. How we will find the integral? The same concept that we learned from our previous lecture. For the integral for tan and sec, we will use the same concept and the same idea here with these two functions. As we can see here, we have two cases. In case all the power is odd, and the second case in case all the power is even. The first case, when we have all the power odd, what we will do? We withdraw one from the both function to get cotan multiply cosec. We withdraw one from the both function to get this part, cotan multiply cosec. This is the first step. The second step, using the simplification relationship, cotan square equal cosec square minus 1. We will use this simplification formula. And the last step, we will solve this integral by using the substitution method, and the assumption will be u equal cosec. This is for the first case, in case all the powers odd. What we will do in case we have all the powers even, we will withdraw 2 from the function cosec to get cosec square. Only from this function cosec, we withdraw 2 to get cosec square. This is the first step. Second step, we will use the simplification formula, cosec square equal cotan square plus 1. The last step, we will solve the integral by substitution method, and the assumption will be u equal cotan. As you can see here, it is same concept and same idea that we use it in our previous lecture. Let's see some practical example. We have this example. Find the integral of the following function, integral cotan to the power 3 multiply cosec to the power 3 x dx. How we will solve this integral? We notice here all the power are odd power, so the integral will be solved by substitution method. The first step, as we learned, we withdraw 1 from the both function to get cotan multiply cosec. After we withdraw 1 from the both function, the integral will become integral cotan square multiply cotan multiply cosec square multiply cosec dx. And after arranging the integral, cotan multiply cosec, we get this part. The second step, we have cotan square, then we will use the simplification formula, cotan square will be equal cosec square minus 1. And we will substitute this value in this part. The integral will become integral cosec square minus 1 all multiply. We will keep this part as it is. Cosec square multiply cotan multiply cosec dx. Now the integral is ready to solve it by substitution method. We will use our assumption. We will take this part for our assumption, u equal cosec, and after taking the derivative for the both sides, du equal minus cosec minus cotan dx. Multiplying the both sides with a negative sign, minus du equal cosec multiply cotan dx. So all this part, it will be equal minus du. And after putting the integral in terms of u, the integral will become integral u square minus 1 all multiply u square du. And after open the bracket, we will get this result. Now the integral become easy to solve. We just increase 1 in the exponent and divide it to the new exponent. And this is the result of this integral in terms of u. The last step, we will put the integral in terms of x. Simple and easy. Let's see another example. Find the integral of the following function. Integral cotan to the power 4 multiply cosec to the power 6 dx. As we notice here, all the power are even power. So we will solve this integral by using the substitution method. What we will do? We will withdraw 2 from cosec to get cosec square. So this is cosec, we have 6. We withdraw 2, it will become 4. So the integral will become cotan to the power 4, we'll keep it as it is, multiply cosec to the power 4 multiply cosec square x dx. Then cosec to the power 4, we need to put it in the quadratic exponent, so it will become cosec square all to the power 2. The second step, we will use the simplification formula, cosec square equal cotan square plus 1. And we will substitute this value in this part, cosec square. Then the integral, it will become like this. And the third step, we will solve this integral by using the substitution method. And the assumption will be u equal cotan. After taking the derivative, du it will be equal minus cosec square dx. After multiplying the both sides with a negative sign, it will become minus du equal cosec square x dx. Notice this value, it will be all this value, it will be equal to minus du. We will put the integral in terms of u and open the bracket, we will get this result. And this is, we find the integral in terms of u. The last step, we just put the integral in terms of x. Simple and easy. Let's see this example. Find the integral of the following function. Integral cotan to the power 5 multiply cosec to the power 4x dx. How we will solve this function? As we notice, here we have odd and even power. We will look at the power of cosec. If it is even, then the integral it will be solved by substitution method. And if the power is odd, then the integral it will be solved by integral by part. Here we have even, then it will be solved by substitution method. What we will do, we withdraw 2 from cosec to get cosec square. So the integral it will become integral cotan to the power 5, we will keep it as it is, cosec to the power 4, draw 2 to get cosec square. It will become cosec square multiply cosec square x dx. Second step, we have cosec square, then we will use the cosec square formula. Cosec square, it will be equal cotan square plus 1. And we will substitute this value in this part. The integral, it will become integral cotan to the power 5 all multiply cotan to the power 2 plus 1 all multiply cosec square x dx. Now we will use the substitution method. We will take our assumption cotan. U it will be equal cotan x, and du, after taking the derivative for both sides, du it will be equal minus cosec square x dx. And multiplying the both sides with a negative sign, then minus du it will be equal cosec square x dx. Notice all this part, it will be equal minus du. After that, we will put the integral in terms of u, and after opening the bracket, we will get this result. Now the integral become easy to solve. We just increase 1 in the exponent and divide it to the new exponent, and we will get the result of this integral in terms of u. The last step, we will put the integral in terms of x. Simple and easy. This is for today, and see you next time.